Hello, algebra students. I'm going to be giving you some notes today on page 34 in your notebook. The last video explained what slope was and how to calculate it. This video is going to talk about the 4 different types of slope and why they're called that. So, the first one we're going to mention is positive slope. So a positive slope goes up when you move from left to right. So if I take my pencil and I go across it from the left side to the right, it's going up. The pink line is positive. And so when you do the calculations, you will also see that your answer turns out to be a positive number as well. And just as a reminder, on a line, the slope is going to be the same between all points on a line, no matter which 2 points you choose. Let me demonstrate that now. So remember that slope is change in y over change in x. So we're going to take our second y, subtract our first. 5 minus 3 is 2. So my change in y is 2. Let me show you how that looks on the graph. The y-axis goes up or down. So we're going to go up 2. From 3 to 5, we went up 2. Then we're going to turn and go across 1, 2, 3. Our change in x was from negative 3 to 0. It went up 3. So if we put those together, the change in y was 2, the change in x was 3, the slope is 2/3. Let's do that again. From 5, our y, to our y, from 5 to 7, it went up 2. 1, 2. From our x 0 to 3, it went up 3. 1, 2, 3. So you could count the squares, or you could do your change in y over your change in x. But either way, you're going to get your slope is 2/3. Same thing here, from 7 to 9, up 2. From 3 to 6, 1, 2, 3. This one also has a slope of 2/3. It's linear, and so the slope will stay the same. Now let's look at a negative slope. Hold on, let's label this one positive, just to remember. Negative slope goes down from left to right, like this blue line does. If I run from the left side of the graph to the right, it is going down. So let's calculate our slope, and you're going to see that our answer is going to be a negative number. So our y goes from 2 to 1. It goes down 1 square. Or if you want to do change in y over change in x, 1 minus 2. Second y minus first y. 1 minus 2 is negative 1 because we went down 1. Our change in x, 4 minus 0 is 4. So this tells me we went down 1 and we went right 4. 1, 2, 3, 4. From this point to this point. So the slope of this line is negative 1/4. Next, let's look at the green line here. The green line is called a 0 slope because it's horizontal. If we pick 2 places on this line, anywhere you like, it doesn't really matter. Let's say we're here and we go here. Notice that we're not going up, we're not going down. We're only going across. Let's put our points here so you can see the change in y over the change in x. So my y's are both negative 2. From negative 2 to negative 2, it didn't change at all. My x's went from negative 1 to 3. It went up 4. 0 divided by 4. It doesn't really matter what you have here. 0 divided by anything is still 0. So it's horizontal. The slope is 0. That's very different than no slope at all. So on this one, 0 is on top. Watch what happens when we have a vertical line. It goes up and down. So let's pick 2 points. We're going to pick these 2 points. This one's located at 5, 6. This one's located at 5, 3. So my change in y from 6 to 3 is going down 3 or up 3, either way. It doesn't matter when it's no slope because the change in x is 0. Whenever you divide by 0, it is going to be an error because you can never divide by 0. The definition of dividing by 0, the definition of dividing is to break into even groups. If you try to divide with 0, you're not breaking into any groups at all. So it goes against the definition of divide. That's why it's called undefined. If you put anything into a calculator and divide by 0, you're going to get an error message. Another way to remember that this is no slope, not 0, no slope, is because it's vertical. You cannot walk up a wall. There's no slope possible here. Here you got a slope that you would climb up. You can do that. Here you've got a slope going downhill. You could do that. Or this is completely flat. You could walk straight across. This you cannot climb. You can't walk on a wall. So no slope is the wall. And remember, for the wall, 0's on the bottom, which is a no-no. All right, now let's calculate slope looking at the graph. Here's the second part of our notes. So let's start with line A. Now you might be able to tell right away that line A is a negative slope. It is going down from left to right. So we want to calculate that slope. Hold on, some of my numbers got erased. We want to calculate that slope, and so we're going to pick 2 points that are precisely located at an intersection. So I picked this one right here, 3, 3. See, this point is exactly at 3 and 3. Or I could have gone over here and did 5, 1. See, that's located precisely at the location of 5, 1. Or up here, 0, 6 is a good spot. It doesn't matter which 2 points you use. Any 2 points on a line will have the slope of the line. So I could use these 2, or these 2, or these 2, any of them. They're all going to turn out to be exactly the same when you simplify. So let's do these 2. For this one, this is located at 3, 3. This one's located at 5, 1. So let's do that here. 3, 3 to 5, 1. Our change in y from 3 to 1, change in y, remember, looks like that. So we're going to take our second y, which is 1, and we're going to subtract our first y, which is 3. 1 minus 3 is negative 2. Now let's do our change in x. We are going to take our second x, which is 5, and we're going to subtract our first x, which is 3. 5 minus 3 is positive 2. So negative 2 divided by positive 2 simplifies to just negative 1. That is the slope you will have everywhere on this pink line. Watch. From here to here, I'm going to go down 1, right 1. Negative 1, positive 1. Here I'm going to go down 2, over 2. Negative 2, positive 2. From here to here, I'm going to go down 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5. It's going to be the same between any 2 points that'll always simplify to negative 1. Let's look at line B. So on line B, we're going to use this point here, and then we need to find another one, like let's say right here. Those 2 points are going to give us our slope. And so this one is located at 3, negative 2. This one's located at 0, positive 2. So we're going to go from 0, 2 to 3, negative 2. We're going to do our change in y over our change in x. So from negative 2, we're going to subtract 2. Negative 2 minus 2. Now the x's, 3, minus 0. Negative 2 minus 2 is negative 4. 3 minus 0 is 3. That is the slope of the blue line. Let's look at line C. Line C is this green one. You could probably tell it's positive. It's going up from left to right. And so here's a point we're going to use, and then anywhere that we can find another place that's at a perfect intersection, like say right here or right here. You don't want to use this because this is not lined up with the x-axis. So we're going to go right here. Let's use this point here, 2, 3.
Samuel Durkee, please come to the media center. Samuel Durkee, please come to the media center.
Sorry about that interruption. So this one is going to be at 2, 3. This one's at 4, 6. So we're going to go from 2, 3 to 4, 6. So you can see another way to do this instead of subtracting is just looking at how much it changed. 3 to 6, it went up 3. 2 to 4, it went up 2. So our slope is 3 over 2. The last example is line D. Line D, we're going to pick any 2 points you like. Let's say we go here and here. This one's at 1, 8. This one is at 4, 8. And any 2 points will work because our change in y everywhere on this line here is going to have a y of 8. So from 8 to 8 is 0. Change in y is 0. And from 1 to 4, we went up 3. It doesn't matter what the number on the bottom is because 0 divided by anything is 0. Line D is a 0 slope, not a no slope, not undefined. All right, that is the notes for types of slope. Please contact me if you have any questions.